So thanks for the invite and for the opportunity to present EOSC Data Commons. I'm presenting these slides on behalf of the consortium, but a special thanks to my colleagues Enol and Xavi for helping me out with the preparation of them. So without further ado, this is the outline. I'm presenting the motivation of the project, what's the implementation plan, some of the use cases that are doing the validation of the concept of the project, and then finally I'll end up with the progress, the challenges, and the future plans of for the project. So let's go ahead with the motivation. So if you see the name EOSC Data Commons contains this commons word. So I was curious about knowing a little bit more of it, and I was digging up more information. So the term refers to a concept back in the medieval age where people basically shared a space with soil, plants, trees, water, animals. And there was a community around this shared space trying to make a common good with it, right? So this is the analogy we use. The concept has now been used outside of this primary idea. Now coming to the digital age, we see the same concept in a shared space where people can share knowledge, share code and software, data, infrastructure, and everything, right? So it's similar idea, and that's where the analogy comes from. Then in particular in Europe, we have the European Commission with the European Open Science Cloud Initiative, where it's trying to build this shared space where researchers across Europe can basically find data, reuse it, deposit, and also access tools and services across the continent to basically advance research. So what is EOSC Data Commons bringing to EOSC? The project is bringing these two services. So on the left of the screen, we have what we call the EOSC Matchmaker. And the idea behind this service is the service is aggregating a collection of data repositories. The idea is that you have a single entry point to discover data using AI-based search. Then the service is also aggregating tools from across different repositories. Again, same concept, single entry point to discover multiple tools. And then the matchmaker has also a component about a fair assessment with the idea that every dataset should be assessed against the first score to improve the reusability of the datasets and research outputs. This is the idea of the matchmaker, basically a single entry point to find data and tools and making it fair. On the right side of the screen, you see what we call the EOSC Data Player. This is another service. And the EOSC Data Player is aggregating virtual research environments and compute platforms all together, again, as a single entry point to distribute workloads. So the idea is that the user, the researcher, is going to interact with the EOSC Matchmaker to find data and tools. Then when that's done and that's completed, the user will will pair one dataset with one tool and click on run, and the system will prepare automatically what we call the package for processing datasets. And this package is sent from the matchmaker to the data player. Then the data player receives the package, inspect what's in it, and decide to what compute engine is going to send the package to. And that means basically doing everything automatically for the user in terms of providing the data that the user selected, providing the tools and all the dependencies and the environment needed to execute the analysis. So that's the whole idea of the project. And why is it relevant? So the ultimate goal is to enable faster time to results. So normally researchers need to go to one place to find the data, then they need to go to a separate place to find the right tools, and then they may need to go to a separate place to do the analysis, meaning download the data, download the tool, install everything, and run the analysis. With Data Commons, we want to simplify that with a single entry point, a single space, a single place for everything. So you don't have to switch between places, you don't have to do the manual download, you don't have to do the manual installation of things. Basically providing everything done for reproducing this analysis and doing new analysis. So that's the ultimate goal. Then the project itself was funded in this call that I mentioned here, Horizon Infra 2024 EOSC 0105, with a budget of 7 million. The project started in the 1st of April in 2025, and it's going to last for 3 years. We have in the consortium 22 partners. Some of them are providing repositories. Some of them are providing technology to the consortium. Some of them are bringing research communities from across Europe in different scientific domains, and we'll cover the scientific communities and the use cases later. Okay, so we have now presented the motivation of the project and the introduction. I'll now move into the implementation. I'm going to start with the overall architecture of the system. But if you want more information, we will share the slides with you. And there are the links here to the deliverables 3.1 and 3.2 in Zenodo, which are available to everybody, if you want to get more exact and accurate information. So going back to the architecture, in orange, you see the two services, the matchmaker and the data player that we mentioned earlier. So we'll now dive a little bit more into those. But overall, the picture is the following. So we have a researcher interacting with the matchmaker to basically search data and tools and pair them. And then for that, the matchmaker is actually aggregating and harvesting information from data repositories and from tool repositories altogether to enable that search. And then when that's done, the matchmaker creates this package for data processing, send it to the data player, and the data player is connected to, as we mentioned, is connected to multiple virtual research environments and multiple compute platforms. And the idea is that the data player is going to basically send the analysis to the appropriate platform, depending on the content of the user selection. To enable the search done by the researcher in the matchmaker and to navigate all the databases, the EOSC matchmaker is also connecting to an LLM inference server to enable this AI-based search. So now I plan to zoom in first into the matchmaker, and then later I'll zoom in into the data player. So let's go with the matchmaker first. So now the orange box is replaced with multiple blue boxes here. So this whole thing is the matchmaker in components. Let me start with the gray repositories, which are, as we mentioned, there is a harvesting done from data repositories, bringing metadata to a metadata warehouse. Then there is a harvesting done by a tool registry, harvesting tool repositories out there. And then again, that's pushing the metadata to the metadata warehouse. So that's enabling the search that the user is able to perform from the user interface. The search, as we mentioned, is we initially started with keywords, but then a kind of a clear goal of the project was to enable AI-based search connecting to an LLM service. So then, as we mentioned, the user interacts with the user interface, select data and tools. When that's found and selected, there is a request to create this package for data processing done by the request packager, and that package is then sent to the data player. So that's the matchmaker in a little bit more detail. Now I'd like to zoom out a bit and map out those functionalities and components with the life cycle of research, right? In the life cycle of research, we may start reusing things or planning from scratch, collecting data and tools, processing the data, doing the analysis, and then preserving the outputs and sharing it with other people. So in this sense, the AI-based search is going to help us reuse existing outputs from other researchers. It's going to also help us plan and collect information to move ahead. The matchmaking done by the system is going to also help us selecting the most appropriate tools for the processing and the collection. And finally, the fair assessment is going to help us preserve and share the outputs of the research project with other people and make it more reusable. So, okay, that's the matchmaker. So I zoom out. Okay, we are back to the original diagram. So we've been discussing the matchmaker. Now let's zoom into the data player a bit. So in the data player, again, the orange box has been replaced with blue boxes here. So this is receiving, as we mentioned, the matchmaker is going to produce this package for processing data sets. The first component in the data player receiving it is the dispatcher. It's going to inspect this package, and then it's going to call the appropriate data access tool and the appropriate compute engines to send the workload either to virtual research environments or to compute platforms. And in case of deploying things on top of the compute platforms, you may have to call deployment tools here. So those are the boxes explaining that here. There is also the option for a second phase of the project in which we want to have virtual research environments to be able to go back and query all the metadata available in the matchmaker. So basically finding data. So users of an existing VRE, they don't have to jump out to the matchmaker. From within the VRE, they can basically discover data and tools, pair them, and then send the package to the dispatcher directly. Okay, so again, mapping this to the life cycle of research. The data access helps with the collection and processing of data from across a heterogeneous set of repositories out there. The automated execution of data analytics is going to help with the processing and analytics steps. And then this package for processing data sets is going to help with the sharing and reusability of the research outputs. Okay, so I went a little bit more in detail about the project and the architecture of the system and the functionality. Now, in the consortium, we also have a set of use cases, and they are basically providing requirements for the system. And then after each release cycle, they are helping us test whether the system is performing as it should, and basically providing a continuous feedback loop to the technology providers to basically iterate and refine the services. So which are these use cases? We have 16 in total, and they can be grouped into 4 categories. Category 1 is virtual research environments. You may be familiar with these. These are normally web portals where users log in and they can upload data, download data. They can create tools or run tools that are already installed in the VRE. So it's a digital space for doing research. That's and making it streamlining the process for researchers. Then we have category 2 is data repositories, and there researchers just go and try to search and find and download data, or also deposit data after the research is done. And category 3 is a combination of both. Some we found in the consortium, some virtual research environments, they not only provide the functionality to upload, download data and run workflows or tools, but they already provide a good wealth of domain-specific data inside the virtual research environment, so the users don't have to go out and find additional data. So for that, we created category 3 because it's a combination of virtual research and data repositories all together into a single space. And then the final category, category 4, is workflows, and this is for basically a more advanced user, more advanced research domain where researchers basically code the workflow So they are interested more in interacting with the services, but from the API or the CLI point of view, not from the user interface point of view. Okay, so now let's dive into each of these 4 categories. So the first one is, I'll go first with the data repositories. We have DABAR by Sarsi from Croatia. We have DANS from the Netherlands. We have FinBIF by the Finnish Museum of Natural History and the University of Helsinki in Finland. Also HAL by CCSD and CNRS in France. We have NFDI for Earth by Technical University of Dresden in Germany. And also Swiss UBase by University of Zurich and Force in Switzerland. So for example, here you see, you can see that DABAR, DANS, and HAL, they are 3 multidisciplinary data repositories, whereas FinBIF is domain specific, is biodiversity. Swiss UBase is social science and humanities, and NFDI for Earth is earth sciences. So it's a combination of data repositories in different countries and different scientific domains or multidisciplinary repositories. Then we have the virtual research environments along with data repositories, all together combined into a single category. Here we have DASC from Zurich University. In Switzerland, we have EODC from Austria. We have TOPANAT and BG by SIB in Switzerland. We have a virtual imaging platform by CNRS in France, and Modama by Jülich in Germany. So again, a collection of multidisciplinary and domain-specific virtual research environments. The next category is virtual research environments alone. This is where people bring the data themselves to do the analysis, and the virtual research environments, normally they bring the tools for the users, or users can also bring their own tools, of course. So in this category, we have Science Mesh by CERN, we have Haddock3 by Utrecht University in the Netherlands, and we have Reproducible Research Platform by ETH Zurich in Switzerland. And then in the last category, the workflows, we have Fair Molecular Dynamics by CIRMMP in Italy, and we have Single Particle Analysis in Cryo-Electron Microscopy by CNB CSIC in Spain. And by the way, I'll share the links to the use cases so you can have more details. There are more information about them in the website, and there is a specific deliverable as well. So I didn't want to spend much time on the details of each of them because there are too many. So I didn't want to basically use up all the time with each of the repository use cases. Right, so now, where are we now in terms of progress, challenges, and future plans? In this slide, I'm presenting the comparison between the proof of concept release back in November last year and the first release last week. So again, more information about this is in the deliverable 3.1 and 3.2, but a very brief summary. In terms of data repositories, for the POC, we have only 4 repositories harvested, accounting for approximately 50K datasets from DABAR, DANS, OneData, and Swiss UBase. With the release last week, we have increased that to 8 or more repositories and 440K datasets from other new repositories. You can see the list here. Tool published in the tool registry. In the POC, we only had 1 just to test everything out. Now in the first release, it has increased to above 5,400 tools. Note that most of these tools are harvested automatically, and only a minority is a curated tool that's been published by someone. So that's why the number is quite huge. But anyway, it's quite an impressive number, I have to say as well. Then for the fair assessment, there was no plan for the POC, but now after the first release, we started gather requirements. So we plan to gradually support the fair assessment toolkit in the next iterations. And finally, regarding compute engines, for the POC, we only had Galaxy, but for the first release, Galaxy is ready along with Jupyter Hub, Binder Hub, and virtual imaging platform. And there are others that are close to production, which is RRP, a reproducible research platform, and Science Mesh as well. So that's about releases and progress up to date. Then what did we find most challenging in the project? So first, challenge number one is the heterogeneity of the data repositories. Every data repository is working differently, and they are built around different assumptions. So we find, of course, a divergent ecosystem of metadata schemas and inconsistent metadata quality. So that's the first challenge, homogenizing everything into something that the AI search and the pairing can work with. Then moving to challenge number two, we are aggregating tools and harvesting tools, but to begin with, there is no agreed terminology on the concept of a tool. So a tool can be seen as something that takes something as input and produces some output. But although that's true, that's also very generic and very broad. So it makes it challenging to basically define or consider what's a tool on how to harvest it. So that's the other second big challenge. Then those two challenges combined together, 1 and 2, makes challenge number 3, which is about matchmaking. So if it's not only enough with homogenizing the metadata we gathered from data repositories and enriching with metadata quality, it's also the problem with how to properly match and pair the data with the tool. The way we do this at the moment is we offer a default suggestion by the system. This is improving with time as we improve the AI part of the system. But of course, we also allow the user to explicitly search for tools that they know they are able to process the data set. So that's a complement that is going to make sure that the system provides a good functionality to the users. And finally, challenge number 4 is about integrating all these compute platforms and virtual research environments. They are all unique and they have different setups. So providing an homogeneous runtime environment for all these different backends is also a complex, adds complexity to our system. Okay, so looking ahead. So we are, as I mentioned, we started in April 2025. We are practically almost halfway through the project. What's left, what's next for the second period? So we want to focus on consolidating and expanding. So basically optimizing what we have, but also we have only onboarded a subset of data repositories from the consortium. We want to complete the onboarding of everybody. Also, we have an open call. I'll share the details at the end of the talk, where external data repositories are happy to express their interest, and we also can take them into account to harvest their metadata. So adding more data repositories is one leg. The other one is adding more services. Again, we have been adding a subset of the services and tools in the consortium, but we want to expand to the rest and also potentially to external service providers. And the same with compute engines. There are a few of them already onboarded, but we need to expand this to the rest. So it's basically a focus on expansion in area 1. Area 2 is so for the POC and the first release, we've been implementing kind of the use cases are in an initial complexity level. But going beyond this, we want, for the second period of the project, we want to basically extend this to more mature real-world examples to basically progressively increase the complexity of the use cases and what they are capable of doing with the system. And finally, the area number 3 for the future of the project is the integration between the EOSC Data Commons ecosystem and the EOSC EU Node. So for that, I have a separate slide, which is this one. So on the right side, you see the matchmaker and the data player we mentioned and described before. The matchmaker collecting, harvesting repositories of data and tool and put everything into a single place, sending the analysis to the data player that's able to basically send this to a compute engine in the backend. So the extension regarding integration with the EU Node that you see on the left side is that we need to provide a way for the tools hub in the EU Node to harvest the analytics tool by the matchmaker. And on the other side, we want the data player to be able to transfer data to the file sync and share service, and also to communicate not only with existing computing engines, but also connect the data player to send workloads to these services in the EOSC EU Node, the application workload manager, container, and VM services, and the Jupyter service. So that's the idea. And the idea that we say here on the right, we say EOSC Node X in the Federation, because we want those services to be deployable by anybody in there with interest to do the same exercise. Okay, so it's all in terms of explaining the project. What I'll do now is I'll try a demo and let's see how it goes. So this is the homepage for the service, the matchmaker. In the about, you'll have a link to the website of the project. There are the two services explained here. And as I mentioned earlier, the idea is that users will interact mostly with the matchmaker, and then the matchmaker will interact with the data player on behalf of the user. So that's why the focus of the demo will be on the matchmaker now. So I'll close this, go back here. So, okay, so I'm logged in. Here you see my name and my email, and I can go to, there is a section called API keys. And for some of them, for some of the compute engines, you need an API key. At the moment, what we are doing is asking the user to enter this private personal API key in the profile in the matchmaker. So if you see, for example, I have configured already my API key for VIP. So if I need to use VIP, I should be able to connect to the service and send workloads to that virtual research environment. And then in the front page, first thing you see is the search box. Is the main interaction with the system to find data sets and tools. But then the system is also presenting you some example data that's already been harvested, a summary of the data sets that are being indexed and the repositories that are coming from. So you see here the list, and also a set of tools that are available. But it's that simple. The initial user interface is that simple. So what I want to do here, let me do one example. In this example, I want to find Earth observation data, satellite data from the Sentinel satellite, from the Copernicus program. The idea is that I find a data set with images from Austria, and I'm going to do an analysis on that, pair that data set with a notebook, and then do an analysis. And so let's see how it goes. So find Sentinel 5P atmospheric data for Austria. So if I search this, let me see. Okay, so the search, so now you have here a chat, you can keep asking things to the AI. But then the AI also says, look, only the first results provide what you are looking for. The remaining are unrelated data sets, covering other Sentinel missions or other satellites like Landsat. And you can see the score of the result here. You can also see a few tags from the data set. You can see the provider, the year. There is also, this is coming from One Data. One Data is kind of helping us harvest those repositories with the special conditions. But in the future, some future requests, what we have is, for example, if I'm searching for this, and this is coming from EODC, the EODC logo will appear here as well. So now in this search, you also have the option to copy and paste the citation. You can even click on source, and that's going to take you to the original metadata. So this is bringing me to the one data space, and you can see here the collection of files within this data set. So now I can click on play, and if you see, the same files appear on the left side. So I can see the files available in the dataset here. If there is something that you cannot find, or let me put it other way, if you need to add extra files to this analysis, in some cases it might be a configuration file for a workflow or a compute engine, you can always bring it here under the additional datasets. So the idea is that, okay, I have my data set selected. I see what's available. So now the system is proposing a tool by default. But because this is Sentinel 5P, I know there should be, or I want to work with a Sentinel 5P tool. So I find this tool, which is already in the tool registry. It's being harvested already. And now next, what I need to do is you need to add files into the system. And for example, there are individual files here, but there is also, the system is also providing a tarball with everything in it. So what I'll do is I'll go ahead and select the tarball and then click on submit. Okay, so now it says it's been submitted. I'm gonna click on, it takes me to EGI Replay, which is Binder Hub on the backend. And it's taking me there, but it says that I need to log in. So I'm logging in with my EGI checking account. Okay. And then after logging in, let me see. Okay, it's taking longer than I expected. Let's give it a second. If not, yeah, that's coming. So this is now launching the dataset and the notebook on Binder. Of course, there is work to be done in the GitHub repository of the notebook to make it compatible with Binder for this to work. But anyway, we've been doing that, and then there we go. So we have here the notebook open already. So I'll go ahead and run everything, and I'll wait for it to finish. It may take, something has happened up. Let me see. Okay. For some reason, this is not working now. Okay. But the idea is I do have a backup option. Let me see. Let me show you. So the idea is that then when you run it, you get after the execution of the notebook, you get this map, and so this is a map of Austria. Oh, sorry. Let me put it. Can I paste it? I'm trying to post this here. Yes. So this is a map of Austria, and what the notebook is doing with the dataset is creating this this map, averaging the concentration of carbon monoxide across Austria as observed by the Sentinel-5P satellite for the year 2024 from January to December, and the concentration of carbon monoxide on those regions, with the brighter area being the one with higher concentration, and the darker one being the one with the lower concentration of carbon monoxide. So that's the idea, and so yeah, that's it. I'm done with the demo. As you may know, well, as you may expect, you can play around with it and let us know how it goes with your examples. And let me go back to the presentation then. So if you want to learn more about the project, I shared already with you the link to the website and the services, and also the link to the use cases. And also, we do have an open call for those who want to participate, those organizations that are not part of the consortium but want to join in and get more information and even participate. At the beginning, we are initially targeting data repositories. So the open call is at the moment targeted to that. But in the second phase, we may consider other options like onboarding your virtual environment or your compute engine into the matchmaker, into the data project, for example. Also, as Ian mentioned at the beginning, EOSC Data Commons will be present at the EGI Conference 2026, and we have a dedicated session. Many people from the consortium will be there if you want to know more and get more information, or even spot a collaboration opportunity. We'll be happy to get in touch with you. And yeah, that's it from my side. So I'm now open for questions. Thank you very much, and thanks everybody from the consortium, because they have been helping me with the examples and the testing and putting things together in the very last minute. So very much appreciated to everybody that helping me out with this. So thank you.
Excellent. Thank you so much. That's excellent work. We already have people have a question in the Q&A box, and then I can also invite them to the panel. And first, the questions from Andres. Andres, you can talk, or we can read your question out. He actually asked, how could you elaborate further on the protocol of methodology employed for the harvest, the metadata harvest of the repository?
Yeah. So before I go ahead with technical questions, I have to put a disclaimer. I'm not technical. I'm not involved in technical activities. I try to answer as much as possible, but if not, we can also take the questions back to the relevant people from the consortium. So in terms of harvesting repositories, we did a first analysis on what was available in the consortium, and the common denominator we found was OAI PMH as the protocol and DataCite as the metadata schema. So we started to focus on those initially. So, and also for the onboarding of external ones, we focus on those. Then for the second period of the project, we do have the capacity or the design in the architecture to develop a specific crawlers depending on different metadata schemas and different protocols. So the idea is that this can then be extended to others. And indeed, for example, we are doing this already with, for example, FinBeef doesn't provide this OAI PMH or DataCite, but still the technical team is working on a specific crawler for them. and being able to harvest that metadata into the system. Yeah, I hope that answers the question. If not, I'm happy to follow up.
Andres, is it happy? Are you happy with the answer? You can unmute you if you like to talk. Otherwise, we move on to the next question from Thomas. Thomas asks about that these numbers, the statistic on the demo, how this 100% and 0%. And I can enable you to talk. Thomas.
Yeah.
Yes, thank you very much. Yes, there are relevance scores which are shown when you perform the research on Data Commons.
Yes.
And the first two results were 100% and 0%, which seem a little extreme to me. So I wondered how they were calculated and what they actually represented, since yeah, it seems a little. I guess it has to be refined, but
you are right. You are right.
You can expand on that. Yeah, thank you.
Yeah, so I can only give a very high level answer, which is this is using the inference server to ask for a similarity score, right? So we depend on the LLM behind it to basically compute this score between what the user is asking and what the dataset is providing in the metadata. I do agree it's quite extreme, and we need to look into it because indeed I see here Austria is part of the region of interest in this second result, and is Sentinel. So it shouldn't be zero. Yeah, we need to look into that. So it's something to refine, and we'll keep testing things and see how it goes.
Thank you very much.
Thank you.
Also, thank you for this question. Thank you. And next one from Nardin. Nardin, and you asked what is the strategy to add more data and repository?
Yes, I'm also from the Panosk node, working in the Panosk node, and I see you have some data of ISIS, for example, and yeah, just wondering what your strategy is in this respect, and or also just quickly browsing through the open call. Is it connected to the open call in some respect?
Indeed, yes. So so the strategy has been because we are an EOS project, we are participating in the winter school, in the symposium, and connecting with we take the opportunity to connect with other EOS projects to basically bring additional data repositories into the system. So the Panosk is actually a result of a collaboration in the past winter school in Nice this year. So we ended up discussing with people from Panosk, and they agreed to collaborate. But indeed, actually the open call is exactly targeted for that. So actually you just need to follow the instructions, and the idea is that if you submit, we have a simple PDF or Word document to submit, where we gather information about your data repositories, and then after you share with us your contact details, we arrange a meeting and follow up and decide on how to basically onboard your repository with us. Yes.
Okay, thank you very much.
Thank you.
Thank you, Nadine. Thank you for the question. And then we have a last question from Radoslava. And he asked the relationship with the Rescale project. Do you work? Yes. Do you align with the project? And
actually, I'm not involved in the RIScale project, but I am aware of the similarities. So basically, I think the main difference, and I might be apologies if I'm mixing things up, but then the goal of the difference with Data Commons is we are bringing this discoverability through AI-based search which is complementary to what RIScale is doing inside the consortium. I don't know if that's, I hope it is not wrong. So it's basically a different approach. It is indeed bringing data to compute platforms, but using a different approach. And for example, here also with this orchestration platform, there is a single entry point to distribute the workload across multiple compute engines, which I think it's also a complementarity to what RIScale is doing. So that would be my answer, but I don't know if it's 100% accurate because I'm not in the other project, sorry. But if you have additional comments, please feel free to speak up and we can discuss.
Is that answer the question? Our Rescale is a EGI flagship project. We have some people here. Maybe Marco, do you happy to answer something? Is it? I can. Marco, do you want to say something? About the two projects. I remember you're involved in Rescale.
Yeah, I'm involved with this, and maybe in the future the components from the two projects can be complementary to allow the same goal that EOSC Data Commons have.
Yeah, that's a very good point to raise this issue, and then we really can sit together with the two projects and to see which solution better to serve what kind of use case, community use case. Thank you very much for the question. Do you want to say anything, right, Slava? Sorry if I'm wrong with your name. If you can unmute it yourself, you can talk, or otherwise, are you happy with the answer? Okay. And then we can move to another question from Stephen. Oh, yes, and thank you. Okay, we can move to a next question from Stephen. He asked, is the LLM trained with harvest metadata only? Let me unmute you. I think that's if you can, I guess that's Marco can answer the question.
Yeah, to my knowledge, that's the case. But Marco, I don't know if you know more details.
No, sorry, I didn't get the question.
The question is the LLM trained with the harvested metadata only?
No. We are using open source large language models that are not trained against this data. We are using retrieval augmented generation.
Okay. I hope that's answer your question, Stefan. If you can unmute yourself to talk. Okay. Anyone else? Any question? It's a very, very interesting, very nice talk. Thank you so much, Sebastian. And then very okay, no question. So I want to give a great thanks to your excellent work and excellent talk, and I hope the community will also benefit from this work. And for everyone joining us, we thank you for your participation. You can later contact Sebastian for more detail. And I want to thank you for everyone